Hello everyone, welcome to the today's session. I am Pooja and I'm your mathematics tutor at Learn Big. Today we'll be talking about a geometry topic which is like very similar, like which you have already studied a lot of times, okay? But like in each standard there is something new about that topic. So we'll be talking about that. So the topic for today we have is, let's see, okay, so it is similar to nachos, okay, and it's similar to pizza. Like you every like a lot of people love pizza, love nachos, okay, and the topic is triangles, okay. So this is the topic we'll be talking about. Like there are sandwiches and a lot of food stuff which are like the samosas and all the stuff which are kind of similar to triangles. So we're not talking about all the food stuff, but we'll be talking about triangles. Okay. So before getting into the actual like what we'll be studying in this session, I would like to tell you what are exactly triangles. Okay. So triangles are shapes which have three sides and three angles. Okay, tri means three, so they have three sides and three angles, and they are 2D shapes. Okay, you have to remember that they are 2D shapes, and they are what? They have three sides and three angles, and therefore they are called as triangles. Okay, so let's get into the topic. So what is the agenda for today that we'll be studying? So hashtag one considered types of triangles. So like it is very much necessary that you should be knowing about what are the types of triangle, and what exactly triangles are. I've already told you, and a topic we have is congruency of triangles, okay, and criteria for congruency of triangles. So hashtag 2 and hashtag 3 is all about congruency of triangles. Okay, so let's get into the first part, that is hashtag 1. We'll be studying about types of triangles. Okay, so before getting into what are types of triangle, I've already told you that what are triangles. Okay, so types of triangles are classified on the basis of angles, and I told you that in triangles, what does a triangle mean? It has three sides and three angles, correct? So what it has? It has angles and it has triangles. So first, the classification is on the basis of angle. So these are the types of triangles. Okay. So first we have is equiangular triangle. Now what does that mean? That all the angles are congruent. So a triangle having all the angles congruent is called an equiangular triangle. Okay, so here you can see that this angle, all of these angles are what? Congruent. Therefore this is called an equiangular triangle. Next we have is acute angle triangle. Now before telling what is an acute angle triangle, I would like to tell you what is an acute angle. Okay, so a angle having measurement less than 90 degree is called as acute angle. Okay, is called an acute angle. Okay, so what will be acute angle triangle? A triangle with all the angles as less than 90 degree, all the angles as acute angle is called an acute angle triangle. So all of the angles of this triangle, this angle, like all the three angles will be what? They'll be less than 90 degree. Now next we have is right angle triangle. So what is a right angle? An angle with 90 degree is called a right angle. So what will be a right angle triangle? A triangle having 90 degree angle in it is considered to be a right angle triangle. Okay, so the one of the angles will be 90 degree. Okay, this is the important thing you have to remember, because what is the sum of angles of a triangle? It is 180 degree. So the total sum of all the angles of a triangle is 180 degree. Okay, so if all the angles are 180 degree, so only one angle should be 90 degree, because if all of them are 90, it is not going to make a sum of 180. It will be more than 180, and that is not possible for triangles. Okay, so one angle should be 90 degree. For obtuse angle, now what is an obtuse angle? Angle more than 90 degree is called an obtuse angle. So this is what? This is less than 90 degree. This is at 90 degree. And this is what? This is more than 90 degree. So in this, all angles are acute. In this, one angle is right 90 degree and this one angle is obtuse angle. Okay, so I hope you're clear with this part, classification of triangle on the basis of angle. Okay, now let's get into the next part of classification, that is on the basis of side. Now, what does this mean? Side, how many sides do we have in a triangle? 3 sides, correct? So, the classification will be on the basis of side. Now, what does we have in it is we have 3 types of triangles. Equilateral triangle, in this all sides are congruent. Okay, or congruent means equal. Okay, all sides are equal. So if one of this side is 3, this will also be 3 and this will also be 3. Okay, this is equilateral triangle. If we talk about isosceles triangle, so at least 2 sides are congruent. Now, if this is 3, this should also be 3. But this shouldn't be 3. Like, let's consider this as to be 5. And scalene triangle is what? Scalene triangle means a triangle which does not have any of the sides as equal. Okay, this is the scalene triangle. So, types of triangles are basis on angle and on the basis of side. So, on the basis of angle, we have equiangular triangle, acute angle triangle, right angle triangle, obtuse angle triangle. On the basis of side, we have equilateral triangle, we have isosceles triangle, and we have scalene triangle. Okay. So let's get into the next part of this, that is some questions. Okay, so what you have to do is identify the given type of triangle. So I'll give you some questions and some of the triangles I'll mention, and you have to answer me that the given triangles are what type of triangle. Okay, so here we have our questions. So the first one has 4, 4, 3. Okay, so these are all our questions. So let's see what our answers are. So for the first one, is isosceles triangle. Now, why is it isosceles triangle? Because you can see that this side and this side are of 4. That means that both of these sides are what? Equal. So a triangle with 2 sides as equal is called as an isosceles triangle. Now let's look at what is the second one. That is the scalene triangle. Now, why is it called a scalene triangle and how does we find it? This is 4, this is 3, and this is 5. Now you can see that all of the 3 sides of this triangle are totally different. Like none of them have any angle as same or any side as same. So a triangle which has all the sides as different is called a scalene triangle. Therefore, this triangle is a scalene triangle. Next we have is equilateral triangle. Okay, how does you identify that it is an equilateral triangle? You can see that this side and this side and this side, both of these sides are 3 in measurement. So if 3 in measurement, that means all sides are equal, and all sides are equal, that type of triangle is called an equilateral triangle. Okay, next we have is a triangle which has one of the angle as 90 degree. Okay, there was a triangle which should have one angle as 90 degree. What is that? Right angle triangle. So as this angle, as this triangle, you can see that one of the angle is 90 degree. This triangle is what? This triangle is right angle triangle. Let's look out for this one. Next one. So here you can see that all the angles are 60 degree. So a triangle which has all the angles as equal is called an equiangular triangle. This can also be called as an equilateral triangle. Okay, so this is an equiangular as well as an equilateral triangle. Next you have is, you can see that all of the angles are totally different, correct? So all of the angles are different and we don't know about the measurements of the side. So you may think for a second that it can be a scalene triangle also, but they didn't mention us the measurement of the sides, correct? So if the side measurement is not given, you cannot classify this on the basis of side. They have given us angle, right? So on the basis of angle, you can see there's an angle which is more than 90 degree, and this angle is obtuse angle. Therefore, this triangle is an obtuse angled triangle. Okay, so I hope you're clear with all of these questions and how did you identify that the given question is what and the answer to those are what. Okay, let's get into the next one. So here we are done with the first part of the session, that is #1. So #1 was all about type of triangles and what are triangles, and they're done with the questions as well. Now let's jump into the second part of the session, that is #2. Okay, now let's see what do we have in #2. Okay, here you can see stars and hearts and diamonds. Okay, now what is the purpose of having those? Okay, so I'll tell you what is that. So you can see that if you see both of these stars, they are exactly equal. That means one overlaps the other, correct? So if it overlaps, that means they are equal. Let's see the next one. The heart and the diamond, also you can see that they are exactly overlapping each other. That means they both are also same in the measurement, correct? So these are called as congruent figures. Now, what are congruent figures? Before that, I'll give you an example. You just place like 2 to 3 1 rupee coin or 2 to 3 2 rupee coin and just observe that all of them are equal. Like they look exactly same, correct? So a stack of coins, if you keep on placing the coins over the other, all of the coins are congruent. Okay, if you place a CD, stack of CDs, okay, which we don't use now much, but still, if you talk about CDs, so if you place a stack of CDs, you can see that all of the CDs have equal measurement. So, what are equal, like congruent figures? Figures having same shape and same size are called as congruent figures. Now, what does that mean? Like in the star case, you just saw that both of the stars are what? Exactly equal. If you talk about the hearts, okay, both of them are exactly equal. If you talk about these two diamonds, okay, so they are also exactly same in shape. Now, if they're exactly in shape, such figures are called as congruent figures. Okay, you have to remember this is very important. So figures having same shape and same size are called as congruent figures. So let's have some questions on it. Now let's see that can you identify that are these congruent or not. Is this pair of earrings a congruent figure? Tell me, yes or no? Yes, this is exactly congruent. Like you can see that the one earring is exactly same to the other earring, right? You cannot see any difference in them. Therefore, this figure is a congruent figure. Now let's look out for the next one. Okay, so bottles we have, wow, looking nice bottles. Okay, so in both the bottles you can see that they are exactly same. They look same. Okay, they look same. Does they have the same size? The bottle one is small and the other one is big. Then is it a congruent figure? Like, are they a congruent figure? No, they are not congruent figures, because what does congruent figures mean? Exactly same shape and exactly same size. So these bottles are not congruent figures. Okay, let's look out for this dice. Are they congruent? Yes, both of those dies are exactly same in shape and same in size. Therefore, they are considered to be congruent figures. Okay, let's look out for these guitars. Are they congruent? Yeah, they look exactly same in shape, right? But they are not congruent because one is big and the other is small. So this size is not shape and not same. So what does congruent figures means? Figures having same shape and same size. So as you can see that they are not in the same size, they are not congruent figures. Let's have as example. Okay, so pages of the book, like if you have a book, I'm considering only one book. Okay, so all pages of a book are same. Okay, don't get confused that the written content on each paper is different. You're not talking about the content, you're talking about the figure, like this shape of the paper. So all the pages of the book are same. So all the pages of a book are considered to be congruent. Now in this you can see that I've mentioned two triangles and triangle ABC, and the other is triangle A dash B dash C dash. Okay, in both the triangles you can see that clearly this angle is corresponding to this angle. That means this angle and this are exactly same. And you can see that both B and B dash are same and C and C dash are same. Okay, like BC and B dash and C dash are same. Correct. So these triangles are also called as congruent. So whenever triangles have all of the things present in them which are equal to each other, you have to remember congruent means what? Equal to each other. Okay, so both the triangles are equal in measurement and therefore they are considered to be congruent. Okay, so let's talk about congruent triangles. Now what does congruent triangles mean? We are talking about triangles, so obviously you should be knowing what are congruent triangles. So triangle ABC and triangle DEF, again I'll explain you that angle A and angle D are same. Okay, like by this mark you can identify. Okay, like for C and F you can see that both of them are same. Correct. If you talk about B and E, both of them are same. Let's talk about the sides. Okay, what does congruent figures means? Same shape and same size. Now you can see that all the angles are same. Whenever we classify triangles, it's on the basis of angles or it is side. Now if they're equal, they should be equal in both bases. Okay, let's check if this triangle is equal by sides as well. So you can see that AB, you can see that AB and DE are same. Like this line is the indicator. Okay, you can see that AC and DF are same. Correct. You can see BC and EF is also same. Okay, wow. So that means both of these triangles are equal by angles as well as by sides. So they are considered to be congruent. So here you can see this sign is used for indicating the congruent figures. Okay, so if we are talking about triangles, so in this chapter we'll be talking about triangles, so we will be using this congruent sign only for triangles. Okay, so you can see that both of the triangles are congruent, therefore triangle ABC is congruent to triangle DEF. Now for congruent triangles are what? Same shape and same size again. Okay, so all the congruent figures have same shape, same size. Same goes with congruent triangles as well. But the difference is they should be triangle and other figures are not all triangles. Okay, that's the only difference. But triangles are also a type of figure. Correct. So here we have an example. So here you can see that identical triangles have all three sides and all three angles exactly the same. Okay, let's check for these triangles as well. So this angle is 60° and for this triangle also it is 60°. For this angle, let us consider this to be A E and C, and let this to be X, Y, and Z. Okay, so angle A is exactly equal to angle X. Angle B is exactly equal to angle Y. Okay, angle C is exactly equal to angle Z. That means angles should be congruent, exactly be same, exactly be equal. That is satisfied, correct? Let's check by the sides now. AB is 5, okay. XY is also 5. The first is same. BC is 7. YZ is also 7. AC is 9. And XZ is 9. Okay, so you can see that both of the triangles are what? They are equal in angles and they are equal in sides as well. So both of the triangles are considered to be what? Both of the triangles are congruent. Okay, so triangles having all the three sides and three angles exactly the same in size are considered to be congruent triangles. Okay, so here we are done with the hashtag 2 part, that is what are congruent. What are congruent triangles? So triangles which have exactly the same measurement are called as congruent triangles. Okay, now you are clear with what are types of triangles and what are congruent triangles, correct? So if we talk about the third part, that is the criteria for congruency of triangle. Now what does that mean? See, like for example, we know that if the measurement of both the triangles are given equal, we can easily identify. Like for example, if there's an object and the other object is exactly the same in size, they're considered to be congruent figures. Very simple. But what is criteria for congruency of triangle? Now it may happen that two objects are given, but we have to prove them congruent. Okay, they have given us the figures or triangles, but we don't know are they congruent or not. Okay, like for example, if you have to buy a cloth, okay, which is not of your size, that means the criteria is that size, correct? So that means you have to fit in that criteria and then you can buy that, correct? Same goes with criteria for congruency of triangles as well. Okay, so like if you want to study 10th standard, what is the criteria for studying 10th standard? You have to complete your 9th standard, correct? Same has for the criteria for congruency of triangles as well. So whenever we have two types of triangle, there is some criteria which should be fulfilled, and on the basis of that we can prove that both the triangles are congruent. Okay, so what are those criteria? So the first is SAS criterion. Okay, these are also called as SAS test. Okay, why these are also called as tests? Because this is just just a small exam for the triangles. So if they can pass this test, they will be considered to be congruent. Okay, like that. So let's have the second one, that is ASA test. First, I'll tell you all the types of criteria and then I'll be explaining you each one of them. Okay, so first is ASAS criterion. Second is ASA criterion, AAS criterion, SSS criterion, and we have RHS rule. Okay, now let's get into the each part of these. Okay, so here we have a SAS criterion. Now what does that mean? Side, angle, side. Okay, so we have S and A in four of the test. You can see that in the first one we have SAS, we have ASA, we have AAS, and we have SSS. So what A means over here? Angle. And what does S mean over here? That is side. Okay. Angle, and here S means the side. Okay, now let's get into each of these. So first we have is SAS criteria. So what is SAS criteria? Side angle side. Now you'll be thinking that why side angle side only? Because I clearly told you that whenever we talk about triangles or we classify them, it's on the basis of side or it's on the basis of an angle, correct? So if you want to prove the given triangles as congruent, it should be side and angle again. Okay, so here we have to prove the triangles as congruent. So it will be on the basis of what? On the basis of side or on the basis of triangle. Okay, so side angle side test. Hello? Are you able to hear me, Arindam? Hello? Okay. So first we have is SAS criterion. Now what is SAS criterion? This says that two triangles are congruent if, okay, so to be clear with all of these tests, they are quite easy. Okay, you can easily understand them and I'll be repeating each of those so you get clearly into your head about this. Okay, so two triangles are congruent if, so we have condition for that, they will be considered congruent if two sides, okay, so side angle side, so that means two sides and the included angle of one triangle, that means here we have a triangle and here we have a triangle, in this two sides and what, two sides and one angle, in this also two side and one angle, if both of these equal, then both of those triangles can be considered to be congruent. Okay, let's look how. So if side angle side we are talking about, so let's see which one is the side and which one is the angle. So PQ, you can see that they have given us that PQ is what? PQ is equal, it is congruent to WX. If you see angle Q and angle X, they are given as congruent. So the side category is done. The angle category is also done. We need one more side. So you can see that QS and what? XY are congruent. Correct? QS and what? XY are congruent. So in this case, this and this, if we talk about this angle and this angle, so side and angle is done and this side. Okay, so side, angle, and side. So we have two sides and one angle. Therefore, this category is satisfied and triangle PQS and triangle WXY are congruent by what? By SAS test. Okay, so if two angles and sorry, if two sides and one angle is congruent, then both of the triangles will be considered to be what? They are considered to be congruent. Now here I have a note that is very important to remember. Congruent triangles corresponding parts are equal. Now what does corresponding part mean? Like we just saw that PQ is congruent to XY. Now why congruent to XY only? Why can't we write X? Sorry, WX. Why can't we write XY in place of that? Okay, they have clearly mentioned us by this line that the measurement of both of these sides are what? They are equal. Okay, so the parts which have equal measurement are called as corresponding part. So the corresponding part for Q is what? For Q it is X, for P is what? Is W, and for S is what? Y. Okay, for PQ is what? WX, for PS is what? WY, and for SQ is what? YX, or we can also call as QS or XY. Okay, so getting it clearly, and those part can also be written as CPCT. That means corresponding parts of congruent triangles. Okay, and now this can only be used if you prove that both the triangles are congruent. If both the triangles are not congruent, you cannot use this rule to them. If you prove that PQS is congruent to WXY, that means by CPCT, angle S will be congruent to Y, angle P will be congruent to W. That's how it is. Okay. So let's get into the next part, that is the second criterion, which is the ASA criterion. Now, what is ASA criterion? Angle, side, angle. Okay, in that case, we had two sides and one angle. In this, we'll be having what? We'll be having two angles and one side. Okay, so let's see, what does this mean? Two triangles are congruent if, again, condition for us, two triangles can be considered congruent only and only if two angles and the included side. Okay, so like in the previous case also, the angle should be between the sides. Okay, now in this, the side should be in between the angles. Getting it? So two triangles are congruent if two angles and the included side of one triangle are equal. So two angles and one side now. Two angles and one side are equal to two angles and included side of the other triangle. Let's get to know about this. So you can see that angle A is what? Angle A is congruent to angle D. Okay, side AC is congruent to side DF, and angle C is what? Is congruent to angle F. Now, if you clearly observe in this part that side AC is what? Side AC is between the two angles. Okay, now if this side, these two angles were given and if this side is mentioned, then you cannot prove by ASA test that the triangles are congruent. Getting my point? So the side and this angle should be in between them. Okay, so by ASA criterion, we can prove that both of these triangles are what? Both of these triangles are congruent. Okay, so angle A is congruent to angle D, side AC is congruent to DF, and angle C is congruent to angle F. Then triangle ABC is congruent to triangle DEF. By which criterion? By which test can you tell that? By ASA criterion, you can say that both of these triangles are what? They are congruent. Okay, again the note which I mentioned you previously, that congruent at triangles corresponding parts are equal, and we write in short corresponding part of congruent triangles for corresponding parts of congruent triangles. Okay, I'll give you a minute so you can just have a quick look at the first and the second criteria. I'll just give you a minute, just check this out. Read it once, okay? Just check this one out too. Read the sentence clearly and check the proof as well. So if angle A is congruent to angle D and side AC is congruent to side DF, angle C is congruent to angle F, then triangle ABC is congruent to triangle DEF. Okay. Now let's get into the third criterion of this congruent triangles. Okay, so the third criterion is AAS criterion. Now, what is AAS criterion? It means angle-side criterion. Okay, now let's check what does they say. Two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. So two angles and what? One side. Now in, like, you might be confused why ASA is so different and AAS is so different. In ASA also we have two angles, and in AAS also we have two angles. So in the previous one I clearly mentioned you that the side should be in between the two angles, correct? In this, the third side, that means angle and the next side, or the side is not between the two angles, then also we can consider that the two triangles are congruent. So you can see that angle A is congruent to angle D. Okay, now next we have is angle C is congruent to angle F. Okay, now both of these angles are what? Angle is done, correct? Now we need any side. Now this can be this side or this can be this side, any of the side. So they have given us that BC is congruent to what? Is congruent to EF. Okay. Therefore, this triangle ABC is congruent to triangle DEF by AAS criterion. Okay, getting it now. In the previous, I clearly mentioned you what? That the side should be in between the two angles, correct? So this side was in between these two angles. In the second criterion, the side should not be in between the two angles. That's the difference between the previous one and this one. So if the side is not between the angles and other than the included part, then also by AAS the triangles are what? They are congruent. Okay. Again, the same note, congruent triangles, corresponding parts are equal, and we write in short CPCT, corresponding parts of the congruent triangles. Now, I'll tell you what does that mean for once again. So, now we have proved that triangle ABC is congruent to DF, correct? So, if both of these triangles are congruent, then what? Then angle B is also congruent to angle E, and AP is congruent to DE, and AC is congruent to DF. By what? By CPCT. That means congruent parts of congruent triangles. Okay. So I'll just give you a minute just to read this out and let me know if there is any doubt you have. Okay. AAS criterion, angle side. Two angles and one side, and this side should be not in between the two angles. That is the thing you have to remember. From the name itself, you can clearly identify that in the first case, what was the name? It was SAS test. That means side, angle in between them, and then side. Okay. Then we had ASA test. That means angle, then side, and then again angle. Okay. And then we have the third one is angle side. Okay, that means the angle, then next the angle, and then the side will be coming, not in between the angles. Okay, let's move to the next criterion now. The next criterion we have is SSS criterion. Okay, very easy. So SSS criterion is what? That's a side criterion. Okay, so let's see what does it say. Two triangles are congruent if all the corresponding sides are equal. So if all the corresponding sides are equal, that means the triangles are congruent by SSS criterion. Okay, so let's have a check on this as well. So you can see that MN is congruent to what? MN is congruent to QR. NP is congruent to what? NP is congruent to RS. MP or PM is congruent to what? SQ. So you can see that each of these sides, you can see that each of these side is equal to their corresponding side. Correct. So the yellow is congruent to the yellow part. The blue is congruent to the blue, and the green is congruent to the green part. Okay, so by side test, they are what? They are congruent. Okay, so MN is congruent to QR, NP is congruent to RS, PM is congruent to SQ, MNP triangle MNP is congruent to triangle QR. This is the simplest of all criterions. Okay, so it just simply tells you that if all the sides are congruent of both the triangles, then the triangles are congruent. That's it, and you'll be done. Okay, very easy. This is side test. Okay, now I'll give you a minute again so you can check the whole part once again. So SSS criterion is side. Two triangles are congruent if all the three corresponding sides are equal. So all the three sides, if they are equal, then of both the triangles, then they are congruent by what? By SSS test. Okay, now let's get into the next part. Next we have is RHS rule. Okay, this is again a criterion, but it is a rule as well. Okay, so right angle hypotenuse side test. Now what does that mean? I'll tell you this. Not to worry, this applies for right angled triangle only. Okay, you have to remember this thing, that it applies only for a right angle triangle. You cannot randomly use this for any given triangle. This is only for right angle. Okay, let's check. So two right angle triangles are congruent. So if you have to prove that the given two triangles are congruent, so by right angle hypotenuse side test, you can prove that the hypotenuse, one corresponding side, and the 90-degree angle of one triangle is equal to the other triangle, then both of the two triangles are considered to be congruent. So two right angle triangles are congruent if when hypotenuse, one corresponding side, and 90-degree angle, if all the three criteria is fulfilled, only then the two right angle triangles are considered to be congruent. Okay, let's check this. So you can see that angle B and angle Q, are what? 90-degree. So the first thing is that is the 90-degree part is done. Okay, AC is congruent to PR. Okay, now this is the hypotenuse. Now what does a hypotenuse mean? I'll tell you this as well. So hypotenuse is the side which is exactly opposite to the 90-degree angle. So for example, if like you can see that B is the angle over here which is 90-degree. So AC is exactly opposite to angle B. So therefore AC is considered to be the hypotenuse. So always remember, hypotenuse side is the side which is exactly opposite to the 90-degree angle. Okay, so the hypotenuse case is done, the right angle part is done. Okay, so let's check this if there is any side. So AB, you can see that AB, you can see that AB is congruent to PQ. So all the three criteria is fulfilled now. Okay, hypotenuse is congruent, right angle are there, and one side is congruent. Therefore, the given triangles are congruent by A, like the given triangles ABC are congruent to triangle PQR. By what? By right angle hypotenuse side test. Okay, it is very easy. Just remember right angle. So if there is a right angle, there will be a hypotenuse. These two things go hand in hand. Okay, if a right angle is there, only then you can find a hypotenuse. Now, if only these two things are given and the third side is not given, you cannot use this rule. Okay, it is important that you should be knowing the third side as well. Okay, getting it? So by RHS rule, the two triangles given are congruent. The triangle ABC is congruent to triangle PQR. So two right angle triangles are congruent if the hypotenuse, that is the angle opposite to 90-degree, one corresponding side, and the 90-degree angle of one triangle is equal to the other triangle. Okay, so let's get into the questions now. Okay, so the question is, in quadrilateral ABCD, ACBD, okay, ACBD, AC is equal to AD, they have already given us. Okay, and AB bisects, just a second. So this is B. So AB bisects DA. Okay. Show that DABC, like triangle DABC, is congruent to triangle ABD. So the blue part, that is triangle ABC, like this part and this part, both of these parts, you have to show that they are congruent. Okay, what can you say about BC and BD? So what can you say about BC and BD? After proving both of these triangles, we can talk about BC. So let's see the solution. So the proof first, will write the triangles as it is. So triangle ABC, we're talking about this triangle, the blue one and the yellow one. Okay, so triangle ABC and triangle ABD. AC is equal to AD, which is already given to us by that. Okay, given angle CAB. Now, if you talk about this angle and this angle, they are congruent. How are they equal? Since AB bisects angle A, both of them are equal. So if there is a line which bisects a given angle, it gets divided into exactly two equal halves. Okay, so angle A is angle A got divided by AB, so angle CAB is equal to angle DAB. Okay, now let's see what is the next part. Now you can see that AB is equal to AB. Why AB is equal to AB? That is the common part in both the triangles. You can see that AB is present, like you can see that AB is here, right? So it is present in this triangle also, and it is present in this triangle also. Okay. So triangle ABC is congruent to triangle ABD. How? by SAS criterion. So what was the SAS criterion? That a side, correct, a side, a angle, and again a side. So you can see that this is the side, this is the angle, and this is the side. So by SAS test or criterion, we can prove that both of these triangles are what? Are congruent. And now what about BC and BD? So if both of the triangles are congruent, by CPCT, BC is equal to BD. I told you in the note part that whenever the two triangles are congruent, we prove that both of the triangles are congruent. That means other remaining corresponding parts are also congruent of both of the triangles. Okay, let's check for the next question. So next question we have, so AD and BC are equal perpendicular to a line segment AB. Show that CD bisects AB. Okay, so what you have to show that this CD is bisecting what? This line. That is what you have to show. Okay, prove it. So this is what? This is AD and CB. Okay, BC. The perpendicular part, and this is what you have to show that they bisect. Hint, you have to prove OA is equal to OB. So if you prove that both of these are equal, then what? There is something you'll get at the end, I'll tell you. Okay, so triangle what? In both of the triangles, you have to prove that AOA is equal to OB. So in triangle AOD and triangle BOC, okay, that is this triangle and this triangle. Okay. Next, angle AOD. Okay, angle AOD, that means this yellow angle, that can you see? Both of these angles. Okay, is equal to what? Is equal to angle BOC. Vertically opposite angle. Now what does vertically opposite angle mean? Angle, like if this part and this part, so if they are exactly straight or opposite to each other, they are considered to be vertically opposite angle. So they are vertically opposite angle, therefore they are equal. So angle OAD, and you can see that the 90 degree, both of the 90 degree angles, OAD and angle what? OBC. So this angle and this angle. Okay. Each is 90 degree. Correct. Now side AD and side CB. Right. Okay. So side CB and side AD and BC. So AD is equal to BC. They've already given us both of them are equal. So given. Therefore, triangle AOD is congruent to triangle BOC by AAS criterion. That means A means this angle, then the 90 degree angle both, and then finally the side. So both of these triangles are congruent by AAS criterion. Okay, so what about OA and OB? So as you can clearly see that both of the triangles are congruent. So therefore the corresponding part, like the remaining part, will also be congruent. So by CPCT, both of these segments are what? Congruent, as O. Therefore we can say that O is the midpoint of AB. Okay, so CPCT means what? Corresponding parts of congruent triangle. Therefore, CD bisects AB. Okay, so if O is the exact midpoint of AB, that means CD is bisecting AB. Okay. We have one more question. So quadrilateral ABCD is a quadrilateral in which AD is equal to BC. Okay. And angle DAB AD is equal to BC, and angle DAB is equal to angle CBA. This is already given. Now what we have to prove is triangle ABD is congruent to triangle BAC. That is the first thing you have to prove. So this and this triangle. Okay, the highlighted ones. So let's see. In triangle ABD and triangle BAC, AD is equal to BC. AD is equal to BC, which is already given to us. Both of the angles are congruent again. They're equal. Okay, that is also given to us. BA is the common side. You can see that BA is present in the blue triangle as well, in the other triangle as well. Therefore, both of these triangles are congruent by SAS test. Okay, therefore triangle ABD is congruent to triangle BAC. Okay, now let's do the next one, that is BD is equal to AC. Now if BD is equal to AC, how will we prove that? BD is equal to AC by CPCT. We just proved that the blue triangle and this triangle are congruent. So therefore BD and AC will obviously be congruent by CPCT. Okay. Now let's do the next one, that is angle ABD is equal to angle BAC. Okay, that we have to prove. So angle ABD is equal to angle BAC. How? Again, both of these angles, this angle and this. Both of these angles are what? Again, the part of the triangle which we proved similar, and therefore ABD is equal to angle BAC by what? By CPCT. Okay. So so we are almost done with the whole part of the session for today. Let's have a quick summary of whatever we have learned today, and then with that will be end of the session. Okay, so what is the summary? We learn about triangles. So triangles are the figures which have 3 angles and 3 sides. Then we studied about types of triangles. So types of triangles are based on the angles and based on the side. So on the basis of side, there is equilateral triangle, isosceles triangle, and scalene triangle. Okay, on the basis of angle, we have equiangular, we have acute angle, we have right angle, we have obtuse angle. Then we learned about what are congruent figures. Figures having same shape, same size are called as congruent figures. Triangles having same shape and same size are called congruent triangles. Okay, then we studied about criteria for congruency of triangles. So first was the SAS criterion. So what was the SAS criterion? SAS criterion means that side angle side. So 2 sides and 1 angle should be congruent of both the angles, but the angle should be in between the 2 sides. Then we studied about angle side angle. So 2 angles and 1 side, but the side should be exactly in between the 2 angles. Then we studied about angle side criterion. That means 2 angles and the side should not be in between the 2 sides. That was the third criterion. Side criterion. That means all the 3 sides of both the triangles are congruent. Then we can say that both the triangles are congruent. Then we have RHS rule, that is right angle hypotenuse side rule. Okay, in which we have right angle, we have hypotenuse, and one of the corresponding congruent. Then we can say that both the triangles are what? Congruent. Now I have to tell you a very important part, that there cannot be, like we just saw, that is angle side. So you might think that it can be SSA as well. Okay, but that is not possible, because SAS is not sufficient for congruency. It may make 2 different angles. Here you can see that here it is 11 and here it is 6. Okay, and here the angle is 30° and here the angle is 30°. But you can see that both the triangles are totally making different triangles, correct? So SSA rule does not exist. Okay, we don't have SSA rule, we have only AAS rule. Okay, I hope you are clear with this part of what is the criteria for like for the congruency of triangles. So with here we come to end to our session, and thank you so very much for being here to the webinar and learning with us at LearnPick about the congruency of triangle. Hope to see you for the next time. Have a good day and bye.